So anyway, as I was saying, there is a link on the desktop on the virtual machine to go to the PDF of the labs if you want to do that. So while we're still getting everybody set up, a couple of notes here. First thing is that even with our access here, I think we're still going to be facing kind of an uphill battle in terms of getting some of the stuff downloaded as the Jenkins jobs try to run. There's a lot of stuff that gets downloaded. In the past, I've tried to do trade-offs. I've tried to do like virtual images that had absolutely everything and didn't need any internet connectivity, and you end up with like 6 gig images that are impossible to share essentially. And so this time I tried to kind of cut it down to where I just put the very core stuff that we needed on the image, which puts it down to about 3 gig, but that still means that we have to download a lot of stuff, and with all of us trying to do the Wi-Fi, we may see some contention with that. There are a couple of tricks along the way I'll try to point out to you as we're doing the labs to try to help with that. Just realize we may end up in a situation where we can't complete everything in the sessions we have and the time we have because of the time it takes to download stuff. I hope that's not the case, but I just want to put that out there up front. If that does happen, you have the VM, you have the labs, you can do this with the background I give you in the session. You'll be able to take this and go offline after, or out of here at least, and go back to when you have faster internet and be able to finish things up. So if we don't get through everything, we'll do that. Also, we're doing the class in an hour and a half. This is normally something I would do like in about 3 hours at least, or longer. So I've tried to simplify things, but again, we're going to be kind of challenged time-wise in there. My goal is to make sure I give you the information, the background information here, even if we don't get through everything in all the labs in the workshop there, so you've got that information to go with. Okay. A couple other things about the class. One, this is a little bit different than probably some of the other sessions you've been to at Gradle Summit. This is not as much about doing things or using new features of Gradle or ways to use Gradle in there too. What this is about is using Gradle with Jenkins 2. Jenkins 2 has evolved quite a bit from the traditional Jenkins, if you've used that. And probably if you're here, you have. And so this is about how to make Gradle work with that. How do we incorporate it there? You're getting a lot of information from other speakers and stuff about how Gradle works and features and all that. So I wanted to do something that kind of shows you how to tie it in if you've got an existing Jenkins pipeline with some of the new features that are coming out there. So that's really the main point behind this. So again, if you just come in since I started, go ahead and get the VM loaded up. You need VirtualBox. You want to follow through on the labs. There are flash drives up here on the front table which have the image on it. It's a G Summit 17. OVA is the VirtualBox image. You can download that, load it up in there. There's a setup instructions in there, basically just telling you how to load it into VirtualBox. You can follow along with that. There's also hard copy printouts of the labs we're going to do in class. Quick note about the labs. The labs are pretty simplistic. They are pretty much a, type this in, copy and paste in there. I know that's not everybody's cup of tea, but again, in the condensed time frame we have, that's kind of where we've ended up, and it's to help emphasize the points more so than you get to spend 20 minutes or in group discussions trying to think through all that. So just be aware up front, these are pretty simplistic labs. You're of course welcome to take the VM and the image, the pipeline, and work on it more on your own later on. Part of the goal of the class too is to give you a working VM so you can see things and you can take it and experiment with too. All right, with that said, let's go ahead and get started and jump into this. Again, when you get the VM loaded up, go ahead and open up Jenkins. There's a Jenkins 2 icon on the desktop. Password is Jenkins 2, user ID is Jenkins 2, and then that'll give us a head start on that. Okay, let's jump into our presentation. So welcome everybody again to using Gradle with the new Jenkins 2 to construct a continuous delivery pipeline. My name is Brent Laster. A little bit about me. My day job is I work as a senior manager in R&D. I still find some time to sneak in some programming from time to time when I'm not just answering emails and going to meetings. I do some part-time training, Git, Garrett, Gradle, Jenkins, different things in there. You can find some of my stuff, classes on Safari and stuff if you're interested in that with O'Reilly. There's some information about contacting me if you're interested. I have a couple of books, one that's out there now on Amazon, Professional Git, if you're interested and know somebody who needs to learn more about Git, basic or advanced. Working on another one with O'Reilly for fall of this year, hopefully, if I can get it all done, on Jenkins 2 up and running, which will cover all what you need to know about Jenkins 2 and pipelines and how to use it and all that good stuff. So what we're talking about today, though, is continuous delivery, and probably most of you have ever worked with a pipeline of any kind or continuous delivery have seen this book by Jess Humble and David Farley out there, kind of the Bible of continuous delivery, with the idea that, you know, it's a very strange thing we used to have, not so much anymore since we've gone to a lot of continuous delivery methodologies, was that code wasn't deployable for a long period of time. You would get to a point where developers would be done, they would throw it over the wall to a deployment team in there before we had DevOps and all the good stuff that we have now, and you'd really be in kind of a difficult situation. And continuous delivery, on the other hand, is designed around to kind of remedy that. And it has, of course, the goals, deliver things as quickly as possible with low cycle time in there, because we're doing it in an automated fashion. We're taking things and we're running it through a continuous delivery pipeline with some kind of an orchestration engine like Jenkins. And there are plenty of others out there. Most of you probably have heard of them, things like Travis, Concourse, Bamboo, Team City out there. Jenkins is probably the most widely known and arguably the most widely used because of the ecosystem of plugins that it has. But the idea is to do things through an automated fashion and prove that your code is good enough to go out and be deployed. It doesn't mean we always deploy it every time. It means we prove that it is deployable. We put it through a series of tests, the unit test, the integration test, functional test out there. We put it through the ringer to make sure that it actually is ready to go. And we do that in a quick cycle time because we automate all of the pieces out there. Of course, that's kind of an oversimplification of what happens, but that's the basic idea. Frequent automated releases, repeatable. It's a discipline versus an art. We don't have to have, one person who knows how to run this stuff over there, and if he's gone, we're in trouble. It's that we have this repeatable process defined through a set of Jenkins jobs or pipeline tasks, whatever the case can be. Of course, the benefits of that are less risk, less stress, quicker return on investment, improved response to business challenges, all those over there. Fail fast is another good example out there. The idea that even if something doesn't pass the test, at least we know sooner. We know sooner that it's not good and that we need to go back through and we need to update it to get it in there. You can do things like Garrett, if you've heard of that, Garrett code review on the front end as well, even before it gets into your main Git repository, to do code review out there and find out that something's not good. Again, the idea of fail fast. In practice, Git continuous delivery is really three core disciplines together: continuous integration. The simple idea behind that is I am monitoring a source code management system repository. I see something new come in, and I, as the Jenkins or the orchestration engine, again, whichever one you're using, finds that that source has changed, goes out and grabs it, pulls that copy in, tries to do a build on it to see if it's going to compile and complete successfully or not. Continuous testing takes that a step further then. You're taking it and going through a series of unit tests. You might combine your unit testing with your compile time stuff as well, then through integration test, then through functional test probably, and on down the line, whatever you call them, verification testing out there too. Might also be the manual user acceptance test, which is another point here in that you're not having necessarily everything automated. You may still have cases where you have a user or a person looking at that thing, your QA department or something, and being able to run with it and say it's good. Continuous deployment is the final piece of it, being able to take something, put it out to your website, to your product site, or out to whatever kind of container you may want to deploy it with out there so other people can use it. Again, note that part, if desired. And there's a nice quote at the bottom that I really like from a guy named Carl Kalm, which says, continuous delivery doesn't mean every change is deployed to production ASAP. It means every change is proven to be deployable at any time. Again, this idea of, even though we may not be in Netflix, we're rolling out things every day or every week, or whatever the case may be, we are proving that we are at a deployable state. We have passed the kinds of tests and the qualifications that say this is good enough to be put into production if we decide to do that. Okay, so our deployment pipeline, this is a picture from the book. And again, probably most of you are familiar with this. I won't spend a lot of time on it. But you can see the different kinds of stages here. Now, stages in this case, as they use it in the book, you're really talking about a group of jobs or a group of steps you put together in there. We'll talk about stages in the context of Jenkins 2 in a little bit smaller granularity, kind of more as the individual piece we would do within one of these. But you have the commit stage out there to go through and verify that what's been committed into the repository, build looks okay, acceptance stage, exploratory testing in there if you do that, user acceptance testing, staging, the production, and so on. Every change made in here to configuration, source code, environment, or data triggers a new instance of the pipeline. There's a subtle point in there that's worth calling out, and that is that a change made not only to the source code for your product, but to your environment as well, or to your data. All of those things should be under source control. All of those things should be there in a way that if your pipeline detects a change, for example, that something in your database has changed out there, or something in your configuration is out there has changed, it puts it through a process as well. So it's not just your source code, it can be all the parts that make up your pipeline. The change then motivates production of binaries, and a series of tests are done to prove it's releasable. We put it through the testing stage out there, and you get successive levels of confidence as you go on. So in our deployment pipeline we're going to be using here today, and we're not going to have a time to implement all of these stages, but this is essentially what it's going to look like in here, some of the basic pieces. The commit stage, and again this word stage is kind of overused across the tooling that we're using. In terms of the pipeline, it means this bigger set of pieces or processes that we go through. In terms of Jenkins, it will mean a smaller, kind of one of these single blocks in here. The compile and unit test in there to run things through, we'll actually split those out because we'll show you how to do unit testing with parallel, using parallel functionality in Jenkins 2. Integration test in there, we'll see how to use integration testing. We'll use Gradle source sets that have been actually used, moved over from using just the basic testing source sets into some integration testing source sets. And we'll see how to apply some credentials there for a database access as well. Source code analysis, we'll incorporate Sonar. We'll have it running with Sonar. I'll show you how to set up a webhook in Sonar so that you can have your pipeline sit there and wait till Sonar signals it and tells it it's done, so you can get the output of that. Some basic assembly and packaging. We won't actually be modifying this, but you'll see how we do that. We run a Gradle task to do the packaging out there and assembly, then we put it in Artifactory. In publishing artifacts, we'll put stuff in Artifactory, and I'll show you how that works, how integration with Gradle works in Jenkins 2 with Artifactory as well. The acceptance stage out there, we really don't go into that in this session, in this class, just for the sake of time. We do pull out the latest artifact and just grab it for that. In other classes that I do, we actually take that and then deploy it into a Docker container in there. I will show you towards the end of the session how you can use Docker and the new functionality for the Docker steps within Jenkins 2 to do whatever you want to within a Docker container, actually to build a Docker container from a Jenkins 2 step, and how to actually run commands within that Docker container, having it auto-mount volumes and that sort of thing. And then finally, user acceptance test in production. Real quickly here on our, so this are steps here we're modeling as stages in the Jenkins pipeline script. There is some Linux specific implementations along the way, so if you were going to translate this to Windows, your VM is using Ubuntu. If you're going to translate this to Windows, you might have to change a couple of things along the way. I'll try to point those out. We're leveraging Jenkins wherever possible. What we mean by that is kind of where we've had a choice of doing this with Jenkins or one of the other tools. I've opted to do it through Jenkins to show how that's done, using some of the free versions of the products out there, the Artifactory Community Edition and so on, and kind of just a light treatment of each area and selected technologies. All right, so let's talk real quickly here about what is Jenkins 2. I'm using that term a little loosely, but Jenkins 2 essentially is the next evolution of Jenkins. Who here, I assume everybody has used Jenkins at some point in the past? Most of us have, yep, okay. So if you've done stuff with Jenkins previously for any length of time, you've probably been doing it mostly through freestyle jobs. We're going into the web interface and you're actually filling in web forms more or less. You might have gotten into some of the REST API stuff and some of the lower level API, but most people are working with the web forms and going in and creating their Jenkins jobs that way, and then having Jenkins jobs that link together so that when one finishes, it starts off on the other one running out there. That's traditionally how Jenkins has been implemented. And it's kind of gotten behind the curve, honestly. It kind of got behind other things like Concourse or other things that did containerized CI out there, those kinds of things. And so what they did with Jenkins 2.0 is they really took a series of things they called the pipeline plugins and implemented that in Jenkins. So the idea now is that while you can still do freestyle, you can create your jobs as pipeline jobs. Pipeline you can think of as effectively as a Groovy program with a special DSL, domain-specific language, for Jenkins 2. So you can toss in some Jenkins 2 steps in there as well. So instead of having to go in the web forms and fill out your jobs and put in all the pieces in there, we actually can write a script, a program, which most of us are more familiar with if we're programming from the programming side of the house, to create our pipeline in there. More to the point, some of the nice things you can do with that is you can actually take that code and store it outside of Jenkins. You can take your programming script, your pipeline code, store it as what's called a Jenkins file. In the same way you might have a build.gradle, that kind of thing, you have a Jenkins file. It's an external file that contains your code for your pipeline, and you can now store that in source code. So you can do things like code review it. You can do things like track the history of it. You can do things like keep it safe and not outside of Jenkins. You're not having to back up all your configuration stuff anymore or use some kind of special plugin to do that. It really becomes, as we talked about continuous delivery, another piece of data or piece of the pipeline that you can monitor for changes, and you can change as you need to. Also, a couple of other things they've added: an advanced interface, Blue Ocean. Won't have time to get into that today. That's mainly a visual interface. If you are coming from the web style of using Jenkins traditional thing and you're not familiar with programming, that's probably the best interface to use there. Otherwise, it's more of a pretty front end on things. It can be nice to use in there. And we've already talked about most of the things on the right-hand side. These are some of the technologies we'll be using in this pipeline. Of course, Jenkins, Git for source management. You could do the same kinds of things, and Gradle for build engine automation. You could do similar kinds of things with things like Maven, for example, or Subversion out there. Sonar Cube, I'll probably tend to call this Sonar still. Used to be Sonar, but Sonar Cube is for code analysis and metrics. Jacoco for code coverage, Artifactory for binary artifact, and of course Docker for container and image creation. Those are all the different things we'll be using in here. So when we log into Jenkins 2, there is a new kind of process you go through to install it. It's a little bit different. But once you get Jenkins 2 set up, you'll have the opportunity to create, you'll be on the dashboard again. Ours will be at localhost 8080. And you'll have the new item option over here on the left-hand side. And then you'll notice you have some familiar looking types of jobs and some new ones in there as well. Very briefly, a couple of things. There's a freestyle project still in there. You can still do freestyle in Jenkins, just you always have done. Maven, of course, in there. Pipeline. This is a new type of project which is really intended as a place for you to enter the script. It basically gives you a new field or new form on there where you can type in your code as the DSL script out there, the Groovy script, and put your pipeline in there. We have a couple of others in here that may not be seen for. Folder is actually a way to have a separate namespace for projects, a separate organizational structure. If you're familiar with Jenkins from traditionally, you had views in there. You could create new views. You could filter the list of projects, and that was largely what it was provided you. You had some plugins like the Build Pipeline plugin that would create unique views for you. Folder is really about creating a folder type of structure, much as you would for any kind of operating system task or something out there, a new place to put things in there. GitHub organization, I'll talk about that one in just a minute. A little blurry there and hard to read. Sorry about that. Multi-branch pipeline, there's one on the very bottom, it's kind of covered up there, multi-branch pipeline. That's what we'll be using here. The idea with the multi-branch pipeline is I create my Jenkins file, my script that defines my pipeline, as a separate text file. I take it and store it in source control. And I can then point to Jenkins at that location in source control and say, go out there and look at that and see if there's a Jenkins file there. If Jenkins can find a Jenkins file in a branch, and it's at the granularity of a branch, then Jenkins says, oh, I see a Jenkins file here. This is a marker indication. So it's not, Jenkins files aren't just for recording the code, they're also used as markers. I see a Jenkins file there. I know that means I have a script in there for a pipeline. Let me grab that and create a job for you automatically. And as long as the Jenkins file has valid syntax, it will go out and create a job to build that pipeline on that branch of that project. It will also scan other branches out through there and actually look for any kind of Jenkins files in them. So you can create versions of your pipeline that differ depending on what branch you're in, which is what we'll do in here today. And Jenkins is able to go out through this type of project, look for that, and create jobs for you automatically. The GitHub project takes it a little bit step higher. GitHub organization, if you're not familiar with that, a GitHub organization is a way to encapsulate a series of projects on GitHub which have maybe something in common. You can have teams and collaborators on that and a set of projects. But this takes the multi-branch pipeline and moves it up a level to the projects. So that kind of project will go out to a GitHub organization. For each project in the organization, it will find all of the branches in that project and look for Jenkins files in there. If it finds a Jenkins file, it will create an automated job for it. So if your company is one that puts stuff out on GitHubs and has a organization out there, Jenkins can automatically, by virtue of having a Jenkins file in a project, in a branch, detect that, go off and create a job for it and build it. We talked about the Jenkins file briefly, so here is an example of the Jenkins file. Its pipeline script is simply stored in SCM. Pipeline script is essentially Groovy code plus Jenkins DSL steps in there. You can develop in the job, put it in the Jenkins file. You can code your stuff through a pipeline type of project in Jenkins, and then you can copy and paste it out into the Jenkins file with a few modifications in there. Okay. It's not required for Jenkins to build, but if it's out there, Jenkins will see it. We talked about multi-branch projects. This just goes into a little bit deeper. Basically, what you have to do is just configure the location for source code out there. You point Jenkins to the source code location at a minimum, and it goes out and scans it to say, let me look in that project, in that repository, find all the branches, see if they have a Jenkins file. If so, go off and build it. So a multi-branch project in there. Essentially what this slide is explaining, and I'm going through this a little bit fast to try to get us to some of the labs here, but essentially if you add a new branch or a new branch becomes visible in your project, you can tell Jenkins to go off and scan again, and it will see if there's a Jenkins file in there and go off and build from that. If you create one branch from another branch, chances are you have a Jenkins file in there already. The configurations in Jenkins are read-only in this cases because these are building everything is contained in your Jenkins file. Quick note about the domain-specific language in Jenkins. It is Groovy-based, allows orchestrating process steps. A lot of the steps are supplied, of course, by plugins. This is one of the things about Jenkins, and going to Jenkins 2, plugins had to adapt as well. You can find lists out there, and I can point you to some if you want to contact me after outside the class, of things where we talk about compatibility. But it wasn't the case that this was only done in Jenkins. The plugins had to adapt as well. They had to supply steps that would be applicable to use in the pipeline. We talked about it can be written as an external Jenkins file in there as well. One of the other features of using Jenkins 2 in these pipelines is the idea that it can survive restarts. If you stop the master and start it up again, it's supposed to be able to pick up again from where it was. So anything that actually runs in a Jenkins script or anything that's in a plugin, unless it's flagged specifically not to, should be serializable. It has to be able to save its state out there and be able to pick up again from that. Quick note here about using SCM or pulling stuff down from source code in a Jenkins file versus in your Jenkins job. So you may be familiar with the idea in a Jenkins job of actually having a call to something like Git to be able to go out and grab your source code. In the DSL for Jenkins now, there is a Git step where you can supply some parameters. And by the way, parameters within these steps are basically a map. If you supply multiple parameters, you have to have a name-value pair. If you just supply one parameter or one value, then it just takes one. But basically, if you're doing it inside of the Jenkins application, you would write this Git step to go out and pull stuff down. If you're writing this in a Jenkins file, all you have to do is put in this checkout SCM command. The reason is the Jenkins file is going to be stored in with the source code in your repository. So by virtue of the fact that you pointed Jenkins to that repository, it already knows where the source code lives, so you just have to have that checkout SCM step in there to pull stuff down. In Jenkins 2, there's two types of syntax for pipelines. There's one called scripted and one called declarative. Scriptive is essentially your Groovy code with Jenkins DSL thrown in. It's anything you can do in Groovy that's legal to do. I mean, as far as some things are restricted from being able to access lower level objects in Jenkins and stuff, but anything that's legal to do in Groovy, as well with, and the Jenkins DSL thrown in. Notice here there's a form here that fits this. There's a node. Node is kind of like an agent, or we may think of them as like masters and slaves before. Node specifies the system you're going to work on. Then the different parts are typically broken down into stages. A stage granularity would be like a piece of your pipeline, something that does the compile or the unit test or the compile test. Those kinds of things in there are wrapped in a Groovy closure. And the closures typically have these stage things that have a name. Declarative, though, is just a way that kind of is made it easier to translate from traditional Jenkins model to pipeline. So with the scripted part, it's pretty much free form. There is, a couple of things you have to have in there, but it's pretty much free form in terms you can do if statements, you can define variables, all that good stuff. When you get down to the declarative thing, it's much more structured. They expect a certain structure. They expect a pipeline closure at one point, an agent declaration to say what system you're going to run things on, a stage closure, and within the stage closure steps. It's a very defined syntax. It's still groovy-ish, but it's still a very defined syntax. The reason they do that are a couple of things. One is it's more translatable directly from your traditional Jenkins jobs into a Blue Ocean or into a declarative pipeline structure. There is the Blue Ocean editor I mentioned. The Blue Ocean editor writes and reads things in terms of declarative pipelines. It really expects them to be there. You can still display information for scripted, but it displays information in there. And it also has better error processing in there as far as reporting and checking. It can check things up front and report them. If you're using the scripted basically gives you the stack trace. That's essentially what you get. You get the groovy stack trace out of it. So two types of things we'll be using scripted. A node, we saw a node block just a moment ago. So a node block binds code to a particular system in there on the stack. Has a defined number of executors or slots that it can run something on. If you don't have an executor, then Jenkins will sit there and wait until one becomes available. Code between the brackets forms the program to run. You can specify a particular agent out there via the label. Creates a workspace and runs the code. Here's some examples. Node definition in there. Node with a particular agent on here. And then in the parallel step, which we'll talk about a little bit later, you can actually define separate nodes to run the parallel branches on. You probably typically want to do that. You don't want to have everything trying to run on one node in a parallel case, or else you're going to get a bottleneck there. So you can define different branches. Terminology of stage just aggregates build steps in there. Stages are inside of a node block, and stages take a name, usually corresponding to the function. Here's an example of a stage. We give it a name, there's a node definition for the main part of our pipeline. There is a stage in there, and then there's a step in there to call out and get source code for Git. Here's another stage that does some archiving results. You can see calling a JUnit step in there and an archive step in there as well. Git, has everybody used Git? Most people use Git, okay. I'm going to kind of skip through this in part. This is kind of an intro to Git to talk about that. Basically, there's a local repository, remote repository. You push things through the local process in there and then get them out to the remote side. So your workflow most of the time is going to be adding a step, adding code in there, then stage it, committing it to get it to the local repository, pushing it over to the remote side, and so on. Typical workflow, get an it or get clone the repository down, add things in there to stage them, commit, and then push out to the remote side. One other quick note here about the Jenkins interface. If you haven't got a new version of Jenkins in a while, they have split up the configuration into two different pieces. There is a configure system here and a global tool configuration. The way I tend to think about this is not entirely accurate, but is configure system, system equals servers. So if I have a server set up for that, if I have an Artifactory server, if I have some other kind of server, a Sonar Cube system out there, it usually goes into system. Think of system as servers. And then individual tool configurations, things you can run from the command line, typically go in the tool configuration part. Which brings up a point here, as we'll use to talk about in our first lab, and that is how we tell our pipeline to be able to access the tools that we have defined. Using a pipeline in Jenkins is still kind of the same process. We have a plug-in perhaps to get this functionality we need. We define the tooling globally. We set up servers, we set up whatever we need to globally in the global configuration, and then within the job itself we would point to the particular instance we wanted. For example, if we had a Git instance out there or a Gradle instance, let's use Gradle since we're working with that, we would want to reference the Gradle that we had told Git was installed out on the install path. So we set up, for example, our Gradle instance here that has Gradle defined as Gradle 3.2 for a name, and Gradle home values put in there. This is in the global configuration. In our pipeline, we can define a variable if we want to say, use the tool keyword. So this tool keyword or tool DSL step is how we tell Jenkins in the pipeline environment to go out and get that value of that tool name. We supplied the tool name just as we would for the name we gave it in the global thing, and it gets back the path to that tool, or the home value. So we can define a Gradle location here which says go out to the global configuration for this tool name, give me that value back, and then in our Gradle build step here, we can actually call into that. We can use the Gradle location and just supply the path, the rest of the path to the Gradle tool out there. You can't actually do this as a combined step, which we'll do in the script. You don't have to make the tool call a separate call. You can incorporate the tool call into the actual step out there. All right, that brings us up to lab 1, adding a stage in the Jenkins file. If you've got the handout for that, you can look at that. I'll show you real quick what we're going to do here. And you can go ahead and do this. I'm going to I'll give you just a few minutes here while we're working on that. So the basic idea, once we've got our Jenkins values set up here, once we've got our Jenkins stuff, we've got our VM up and running, we're going to go out to a terminal prompt and we're going to go into a pipeline project. So there's a pipeline project out there, and in that project I have got 6 different branches, lab 1 through lab 6. Each branch has set up for has a Jenkins file set up for each of the labs. So we're going to be modifying a Jenkins file, pushing it out to source control, and then telling Jenkins to go build it. That's the idea. Each lab, we switch to a branch, modify the Jenkins file, push it out there, tell Jenkins to go build it. And we'll add on a little bit to our pipeline on each case. So in the first case, you'll have a Jenkins file out there. Let me see, I think I've got it saved off as a slightly different name. So you'll do a checkout, lab 1 branch, and you'll be editing Jenkins file. I've got this saved as a different name. And it's a very, whoops, I need to make sure I go back to the right branch here. Let's see. Okay. So we're going to have our Jenkins file, and this one is already filled in actually. And I will tell you, for the purposes of this class, I don't care if you copy and paste in here. If you want to do it just to go ahead and so we don't take up too much time with it. Again, I know this is not the most challenging kind of labs here that we have, but we're trying to cover a lot of material in a short time. So this is the completed one for Jenkins 1 after it's been filled in. There's a node description here. It says we're going to go out to one of the worker nodes agents we defined on there. There's a source step. Because this is in a Jenkins file that we store in source control, we can just say check out SCM. We don't actually have to give a location because the Jenkins file is stored in the same repository as our code. Then we have a build stage here, and I've tried to put in where the steps are. Add a build stage that invokes our Gradle tool. So we have a compile stage here, and we have the sh. Sh is a shell command. For any kind of Linux thing you do in Jenkins 2, you have an sh command available to you. That's a shell step. You'll find that will be your best friend as you're figuring out how to do things, and if there's other things you can't do through the normal DSL. On Windows, there is a bat, B-A-T, for batch. There is a batch command as well. But essentially, we've got the Windows, we've got a shell step, and this is all in your labs. Double quote, single quote, tool Gradle 3, bin Gradle, clean compile Java -x test. Let me explain what's going on here. First thing, we have double quotes around the shell step. What's the difference between double quotes and single quotes when you're talking about Jenkins DSL? The main difference is double quotes allow values to be interpolated. They allow this $ bracket substitution in there, okay? So if you need to interpolate something, a variable value or something, put that thing in double quotes. The single quote here is wrapping our Gradle command. So we're saying use the tool, use the tool DSL step. I guess I can point on here. Use the tool DSL step, go out, find the thing named Gradle 3 in our global configuration. That will then in turn substitute in that home path from our global configuration and put the Gradle executable out there. And then we're saying run a clean compile Java -x test. The -x, again, most of you are probably familiar with Gradle in this case, just says don't run the test task. There's things out there, Gradle, that look like test. Don't run them in this case. We're going to save them for a different stage. So we're still doing a little bit of kludge here in that we're saving this off. We're telling it not to run the test task. So what do we do after that? After we have that, make our changes in our file. You'll save it, exit the editor. We're going to do a commit. It's going to tell me that I've already got everything up to date, but in your case, once you do this, okay, and then it says, okay, you've got everything up to commit, then you're going to do a push out there, and that will push it out there. So what we're doing, again, mine's already up to date, is we're modifying our Jenkins file as an external file, we're saving it, we're pushing it out, we're committing it into Git, then we're pushing it out into the branch. When we go into Jenkins, we're going to actually create a new item. Let me just do a new one here and I'll show you. I think I suggest you call it G Summit 17. I'll call mine demo here for purposes in here. We're going to create a new item and scroll down. We're going to make it a multi-branch pipeline. Okay, so multi-branch pipeline. Click on OK. And I'll show you what's happened, and we'll go into the configuration step for it. So we're telling Jenkins we're going to create a multi-branch pipeline job. We're going to scroll down here, and the only thing we really have to configure here is to point this to a source repository. Now, for simplicity, I have a repository stored on this VM. Okay? I could have done it to GitHub, but then we would have had to worry about having everybody get credentials to GitHub. Some people would have two-factor authentication and so on, and it just becomes more of a challenge to try to do that in a classroom environment. So in this case, I'm going to add source. This is all in your lab again, and the path out here is opt-get. So it's in the opt area, pipeline.get. This is in your lab, but I'm doing this to show you what's going to happen. Opt-get pipeline.get. I'll save it. Notice here that before we do that, it says, where is that? Build configuration by Jenkinsfile. That means, and it's really the only choice currently, that means Jenkins is going to go out, look for a Jenkinsfile in each branch of this project, and if there is one, build it. So let's see what that looks like. I'm going to save that. Yes, sir?
The path is too small, can't read it.
It should be in your labs. If you've got the lab there, document, lab 1. If you don't, there's still some hard copies up here. It's opt-get pipeline get. Now look what happens here when we do this. Once we tell Jenkins this is a new multi-branch project, it automatically goes out and says, and again, I apologize, this is kind of blurry and hard to read. I'll read what it says here. It says, I am looking to this repository, setting origin to opt-get pipeline.get, fetching upstream changes, blah, blah, blah. Scene branch, not necessarily the best grammar, but scene branch and repository origin lab 1, lab 2, lab 3, lab 6. I see 6 different branches out there, 7 if you count master. It says scene, 7 remote branches, checking branch lab 2. Hey, Jenkinsfile found, meets the criteria, scheduling a build. Checking branch lab 6, Jenkinsfile found, met criteria, scheduling a build. And it goes through all this. So by virtue that each of these labs, or each of these branches, has a Jenkins file in it, Git automatically goes off and starts building that. Now, one other thing about this, because somebody will ask, and you'll notice over here on the side, if you see it, you can see there's things running for this. One other piece about this, if I go back into my configuration demo, and you can see actually demo then becomes a project with a different job for each of those branches. Somebody will say, well, what about if I don't want to have all the branches? Well, in that case, you can go in here under the multi-branch stuff. Let me go under the repository. There is an advanced button, and you can have include and exclude branches. So, for example, if your project had production branches of a certain naming pattern out there too, and you only wanted to have Jenkins work with them, but not the ones you're using for experimental or new features or something like bug fixes, you could configure that in here. You could configure another job that just tries to build things for bug fixes or for features that might need a slightly different pipeline. Perhaps it doesn't need a user acceptance test stage on the end. So you could create different jobs in here. But what Jenkins does is it actually creates this demo. This is our multi-branch pipeline job, and you can see it actually going off here and building these pieces along the way. Are you guys getting, if anybody's done this yet, are you getting lab 1 done yet? Has it built successfully? Okay, it's still probably downloading a bunch of stuff. I think I am lucky because I've got some things already downloaded here. What I would suggest, I did this intentionally to show you that it's going to go out and create these jobs for all this. In order for us to make progress in the time we have, I would suggest that you go off and kill any running jobs for labs 5, 6, and 4. 4, 5, the last 3. That'll give the first 3 a good chance to go. The way you kill off a job in Jenkins that's building is there's a little red X out here. You can click on that and just say OK. Okay, so I would say once you get lab 1 going to the step, go ahead and kill off any of the jobs that are building for 4, 5, and 6. We'll have time to go back later on, but what happens is Jenkins tends to get caught up in trying to run everything for these 6 jobs and download everything. All right, so it is 10:05. I think we've got a break scheduled here at 10:10. Yeah, so what I'd like for you to do is go ahead and get lab 1 running. I don't think it'll take very long. When it's doing this part, I suggest again killing off 4, 5, and 6, jobs for 4, 5, and 6, because that'll give labs 1, 2, and 3 time to run. And then let's take a break and we'll start back in at 10:20 with lab 1 done. Now, I'll also mention some of these jobs, if they do, will fail because we haven't got everything fed into them. It's by design. What Jenkins is doing, he just says, I see a Jenkins file out there. I'm trying to build it, whether it's good or not. Some of these things will have pieces that we're adding. So go ahead and work on lab 1, get that running. Let me know if you run into questions, and then we'll pick back up again at 10:20 after the break. We'll go ahead and start moving a little bit faster into the other different sections here. We'll talk about using shared libraries, doing parallel processing, Sonar, Artifactory, and Docker. All right, let me know if you have questions, and if you're not coming back, thank you guys for coming for the first round. Okay. So what I said is, I guess if you guys are okay with it, I'll just run through the material, more of like a lecture sort of thing there too, and then you guys can do the demos. If you want to work on them while I'm talking, I don't have a problem with that. You might miss something, but otherwise you'll have the VM with you. When you get back to your workplace or whatever, and you've got better internet access, you can run through the steps, and if you have questions, let me know. But I'd like to make sure I cover the material rather than stopping and missing, not getting to some of the content. Does that work for everybody? Okay, cool, thanks. All right, let's talk about, okay, adding a new branch. We've already mentioned this when you add new branches. One thing to keep in mind here, if you have a multi-branch pipeline and you add a new branch and that parent branch has a Jenkins file in it, guess what? When you create a new branch off of that, it's automatically going to get that Jenkins file inherited. Okay, if you're doing it like through Git, for example, it's going to automatically get a Jenkins file in a new branch, so it's going to scan it and go off and do it. So just be aware of that when that happens. Again, what happens is we create the multi-branch project. Jenkins creates a project for each one of the branches in there. The stage view is the new kind of the output view in the project for it. And I can jump into my lab or into my system here and probably show you a little bit better. If your lab 1 has finished, or you've got a lab that's finished, you'll be able to do that as well. If you go into the actual lab there, you'll see you've got these kind of blocks here. So this is the output of this. This is a matrix essentially. Each row represents a run of your job. We only got 1 here, but if I had 2, I'd have 2 rows of blocks there. Each column represents a stage. This is oriented around the stage. So I defined a source stage and a compile stage. It's auto-refreshing. You can see it tells you how many seconds it took and so forth in there. It also is color-coded, the light green being success. If it was red, but more of a rose color, I guess, if you're being picky about it, that would be a failure. If it was a kind of rose striped, what that means is the preceding sections were okay, but that section failed. Okay? You can see this on some of the later jobs if you look at them. Now, one of the things they try to do in the Jenkins, in the pipeline view, you still got the console. You can get to the console output by going over here, this shortcut. Probably most of you know about this, or shortcut. Click on the blue button next to the job and get to the console output. But they also give you some shortcuts here by hovering over this. If you hover over the stage view, you can get and click on that. You can get a look at the log. It'll auto-refresh in a minute and go away. You can turn off auto-refresh if you want. But you can get a look at the log and success or failure in there too. Let's see if I've got one here that I can go to really quickly. that's failed. Lab number 5, let's go into that. I'll show you kind of what the failure looks like on that. So after a moment, after it decides to refresh, oh no, the pipeline hasn't successfully run. But if it had a failure, you'd be able to see that in the logs as well. It would be color-coded red from there. So the stage view is the new way of kind of presenting information about what's ran successfully or not. Again, each row represents a run of the job. Each column represents one of the stages you define in your pipeline. Here's the color coding I talked about with the red stripe. That means the source stage was a good, but this last stage failed. Also notice that it gives you the overall times for these, average times here based on the number of runs out there and how long it took. Okay, looking at this, just showing you some of the pop-ups here. You can go into and you can actually drill into the failure steps here and see what failed. So if you like a visual interface more so than having to pour through the console log, that gives you a way to do it. Replay, I mentioned this here because it's nice to know and it doesn't get covered a lot. There is a new functionality in Jenkins 2 called Replay, and what they do with this is they actually give you a way to try something out again. If you have a run that failed and you want to go in and modify the code temporarily and see if you can fix it, you can use Replay. The idea is I go to that run, I go in, click on this replay link. I can go in and I can type changes in the editor there for the code that was current at that run. Then I can save it and do another run of the job. Now, replay does not save your changes back to the original task. It doesn't save it back to the original script, so you can try things out here. This is a quick kind of try it, see if it fixes it, try it, see if it changes it, go on your way. So, handy little tool there. Quick note about the pipeline DSL syntax. Many functions per Groovy expect closures out there. Many of them can only run inside of a node block. We're talking about the specific steps out there. Steps in DSL always expect mapped name parameters. What we mean by that is if you have to specify multiple parameters, like in this case the get branch, it expects to have a name and a value, branch colon test, URL colon the path out here. If you only have one thing, you only have to put the one value. So if I was only doing defaulting to the master branch, I could just do get and then the URL path out there. Otherwise, you need to explicitly specify multiple values. And a few notes there about parentheses and brackets in the longhand form. But you can see down here at the bottom, this bat, that's what I was talking about for Windows, if you're running on Windows, and you need to do something, if you only have one thing to do, you can just say bat echo hi, have the value and not the name of this the parameter in there. Shared pipeline libraries. Let's talk about how we put things into shared pipeline libraries here. Shared pipeline libraries essentially allow you to create a separate source code repository that has library code that you can then load and share among multiple pipelines. Two modes. There's a general mode, any SCM repository out there. Basically, that's the one we'll always talk about now. Just in case you didn't know it, there is a legacy mode, which Jenkins 2 has its own internal Git repository. You may never use that, but it's out there if you ever need it. It has an internal Git repository it manages for tracking things. The repository structure, this is the file structure organization out there for a shared repository. There's mainly three directories. There's a resources area. This is designed to have extra data files or things you may need to access, such as like JSON data files, that kind of thing. There's a source area, which gives you a structure similar to like a Java source project out there. This gets added into your class path when if you have stuff out there in it. Then there's the vars area. Vars is a little bit misnamed in my opinion. They say it's for global variables, but a function can be a global variable as well. In general, the vars is the kind of utility area. If you want to put a shared library routine out there, put it in vars to make it most widely applicable. If you're doing a declarative pipeline and declarative syntax, that seems to be the only real way it can find things. Trying to do it in the source area doesn't work. So vars is kind of your utility all-purpose place to put functions or things you need out there. Here is an example of a working with shared libraries. So it's available via shared library mechanism here. For example, here's a call. If I look at this, it says shared libraries, blah, blah, blah. This is my folder structure that I have in my source code repository that makes up my shared library. And I have something there just to add a mail message out there to put stuff that's in mail out there. I can then import this. There's also an annotation we'll talk about in a moment. Import that, and then I can just reference that routine out there. Now this particular library thing, when I do this def call, that's a certain kind of structure that I can write my library routines in, and that allows me then to just invoke the library routine based on the name of the file that's in. In this case, the name of the file is mailuser.groovy, so I can call that as mailuser. I can do that because I use this def call syntax. There's other ways to write the library routines, but it's kind of a convenient way to do it. Now, as we create a library routine, shared library, in a separate source code management repository out there, a separate repository. Just like anything else in Jenkins, we have to define that globally, and then we can pull it in to our local project or our local pipeline. So we have to define these shared libraries globally, which means we have to tell Jenkins what do we want to call that in our pipelines, and where do we get to it? How do we get it? So basically, in Manage Jenkins Configure System, there is a global pipeline library section. You can go out and you can define a library there. Basically, you give it a name. You can do things like tell it to load it automatically, load it implicitly. And then there's also a source code management section. The source code management section is just pointing to the source code out there, the repository that has your shared library in it. What Jenkins will do in the case when it uses a shared library is when it starts running that pipeline, it will go out and clone that shared library code down so it is there for it to access. That's what happens. This is how you tell it where that shared library code is. Couple of things about global libraries. They're usable by any script. They are trusted. That means they can call any method. They can do anything out there. You may not want that to be the case. You may not want to be calling lower level build object things in Jenkins automatically. So if you're using a global shared pipeline library, be careful, be cognizant of who has access to modify it, who has access to change things in it, because it can do anything, it has trusted code. There are other granularities out there. For example, a multi-branch pipeline can actually have its own shared libraries that are just specific to that kind of a project. If you create a folder instance, they can have their own shared libraries that are specific to the things in that folder. And basically this source code back here, you're just giving it the name and you're telling it where to pull it from and so on out there. There is a modern SCM, legacy SCM. Basically, before plugins were modified to know how to work with this, before your source code management things were modified, they were called legacy SCM. All that meant was that you had to add some additional information to say, this is the thing I want, this is the version I have. Most everything now has a modern SCM version, so you don't have to worry about that. Using libraries and resources in your pipeline, the default way to pull in a library is just this @library annotation, like @library in the name. Now, one thing to note here, I don't show it on here, but this is an annotation. An annotation is intended to annotate something. I can put an import statement after that to import just specific functions, but if I don't do that, I need to have a placeholder after this, so I'll put a little underscore after that. So if you're not going to include an import or something, then put a little underscore after this so that that will be a placeholder and the annotation won't be trying to annotate your node step or something out there. We can also override versions of the library. We can define, when we define it globally, we can define a version of the library to pull down. That can be a branch tag. That can be a, in this case, like a tag that we had out there for, I think, 1.4 in there. You can also reference a different version, by just specifying that in the annotation call. The library resource goes out and allows you to grab things from that resources directory where I said you might have JSON files or data files out there. And then you can also access third-party libraries using the grab annotation out there to grab stuff out of there if you're familiar with that. You can also load code directly in by using a load command if you have that plugin installed. So the usage here is if I want to load code directly in, like a Groovy program, I can just define a value in a scripted pipeline. In a declarative pipeline, you can't define values like this. Okay? In a scripted pipeline, I can define a variable, say call the load argument, and then that assumes that the proc Groovy has that kind of defined call structure as well. Resources, I'll go over this very briefly. Basically, this was just the idea, again, that we can load in things from that external resources directory if we need to, using the library resource step in Groovy. Okay, lab 2, so I'm going to go ahead and just kind of skip through the pipeline. There's the content here. In lab 2, by the way, you're just going in and modifying the code to change that Gradle build command into a library command. We call it gbuild. There's a shared library already out there, and you're just updating your Jenkins file to make that call to the shared library instead of the Gradle call. Do you have a question? Oh, okay. All right, so running steps in parallel. One of the nice things the DSL has is a parallel step, which allows you to more easily I always had trouble saying that, parallelize. It sounds like paralyze almost, but parallelize operations out there. Parallel, the key to understanding parallel is that it takes a map as an argument. So you have name that you give it for each of the parallel branches you want, then the value is the code that you want to run in that parallel branch, okay? So if you have the map out there, that's the main thing. If you want to run the parallel steps on different nodes, you would put the node definition in there. If the nodes aren't specified, Jenkins is going to try to run it on some unused nodes that it can find. The other thing to know is you can't use a stage step inside of a parallel block. Here's a quick example of some ways to generate parallel code. The main thing to look at on this one is on the left-hand side. This is kind of a dynamic way. Basically, we have defined a mapping here. Whenever you see this bracket, colon bracket, you may be familiar with that, defining a map. Then what we're doing is we're just going through a loop and we're saying for each of these map elements, my name is going to be whatever the step number is, and then the code or the value for that is going to be node, start, sleep 5 seconds, and then done. Not really useful, but you're basically filling in the pieces of the map. So you can dynamically find a map if you want to, and then we just call the parallel step and with the name of the map. So again, we're passing the map to the parallel step. And if you were to look at that over on the right-hand side, that's just running through a set of code. You can see kind of the interleaved parallel pieces. Example number 2 is where we actually explicitly declare the parallel code in the parallel step itself. So instead of dynamically creating it outside and passing it as a mapping call, we just put it in the parallel step itself. And you can see through all the brackets and braces here, basically we have a map here. We have a master name or and then key. Then we have the value being this node code here that goes off. And this one is dealing with certain running Gradle to actually deal with a subset of unit tests. That's its whole purpose here. It's doing one simple test here, but you could have others. And that's what we're doing in the parallel step in the lab, by the way. We're changing it to actually run and run a subset of unit tests that I've got out there for the API sub-project. Worker 2, this is another key here. Here's the value. The value is just a set of code. And what happens, though, when you run this is you get a failure. And the reason you get a failure is because the code that you're looking for, the unit test you're looking for, aren't on those nodes. If you think about it, typically when I'm running a pipeline, I have my stuff running on a particular node, probably downloading all the source there, going off and building it. If I then want to farm it out to parallel structure, those parallel nodes have to have a way to access that same code base. Otherwise, they can't do any work out there. Of course, you could change the parallel structure to be able to pull down the code again. That's wasteful. So Jenkins 2 actually provides you with stash and unstash functions. These are different from things like stash and get. The basic idea here is pretty simple. I create a stash and tell it what I want to stash. It saves it off. Then in the node, any other node can unstash. And those things are automatically available to it. So I stash on the place where I got the source code down to. I unstash it where I need to use it on the other nodes, and you got it. So if I were to do that, let's talk about the Snippet Generator real quick. One of the things that comes up when you start talking about working with Jenkins 2 and this groovy code and doing pipeline as code, and you'll hear that term a lot, pipeline as code. The idea that instead of putting my pipeline in these web forms and freestyle projects, I want to put it into these pipeline scripts. So one of the things that comes up is, what the heck is that Jenkins step that I need to use, and what the heck parameters does it take, and how's the syntax for it? So they created this nice little thing called the Snippet Generator in Jenkins 2. You get to this by going to, on any job, there will be a pipeline syntax link. Look for it like on the left-hand side where you've got the build now and other things in there. You'll see a pipeline syntax link. When you go into that, you'll be in the Snippet Generator, and what it is it is a list of steps that are available to you to use, as supplied by plugins or the basic Jenkins stuff, and it is the list of steps. You click on this, you use the drop-down to find the step you need. Then you can go in and it will give you the parameters, kind of like a little wizard. Basically, you fill in the values, And then there's a magic button down here that says Generate Groovy Code. That will generate the code that you can copy and paste into your pipeline. Okay? This will be your best friend when you start actually trying to do things that you don't have an example for or trying to figure out the syntax for a step. Go to that pipeline syntax link, go to the Snippet Generator, plug the values in, copy and paste the code. In our case, we're going to go back and create a stash and an unstash. So it's hard to see here, but basically we're fixing that problem where the nodes are running in parallel did not have the content. Underneath this source branch, there is a stash command. This is the stash step from Jenkins, and we have it saying we give it a name, test sources in this case. Then we give it a list to say what do you want to include. And we include our build.gradle, we include some of our other directories out there, basically just a separated list of what to include. Then, down in our parallel steps, when we get into that code, we can simply say unstash test sources, and all the things that we stashed in the source area are available on that other node. So if you need to run things in parallel or you need to get things from one node to the other, use the stash and the unstash out there. Once we do that, then our parallel processing will work. Quick note about that, stashing can handle a pretty large amount of stuff. However, it's not intended to be a substitute for something like an Artifactory or being able to, put code into an artifact repository and pull it out and all that. It's intended for more on-the-fly kinds of needs you have in the pipeline between different kinds of nodes. There's also a command to clean out the workspaces. In Jenkins, you're not automatically guaranteed to have clean workspaces. I know that sounds weird, but it's not guaranteed. Or that they'll persist even across time. So there is a workspace cleanup plugin. You have to add a special step there. And that looks a little funny, that syntax, that step syntax. Basically, that's because that plugin doesn't supply a nicer way to do it yet in the Jenkins DSL. So we're having to kind of call into the class that plugin exposes. It doesn't supply a nice step in there. Okay, so after we put that all together, we have our stash in the source area, we have a workspace cleanup, we have an unstash, and we go on our way and we can make it all run. So lab 3 is just going to be leveraging the parallel functionality in there. You're going to be basically putting in the stash and the unstash, using the Snippet Generator, changing your builds out there. One thing I wanted to mention to you guys while I'm thinking about it right now, in each of these, since we're not going to get time to do them in class, in each of these branches, there is a Jenkins whatever the lab is solution file. So that will have the actual solution to it in there as well. Like I said, I know I made this very simplistic, but it's because we're going to maybe be running short on time. So you can look at the solution in there. Also, in the next lab, whatever the next one is, like if you're working on lab 3 and you go to lab 4's Jenkinsfile already has the stuff from lab 3. So it's building on top of that, okay? If you want to make it more fun, more complex, go in and play with it, start changing it, editing it out. But there is a solution file out there. I said on this lab 3, use build now instead of scanning. Real quickly here, the reason for that, let's see, go in here just a second. When you're working in these demo projects, it's worth mentioning, go into demo here. There's 2 ways you can build these things. One is to say scan now, okay? And that will go through and look at each branch, and any branch that's changed, it will go off and try to build if it finds a Jenkins file in there. That may be what you want starting out. However, you can also go into the individual project and click on Build Now. So if you don't want to have it try to go off and try to build every possible branch that it can that finds a changed Jenkins file in, don't do the scan. If you just want to do one project, go into the project and use the Build Now. Okay. All right, let's go ahead and talk about credentials. So we have one of the things we need to be able to do in our pipeline, as in our projects, is be able to have restricted access or control access to some things, for example, and be able not to do things like not have to expose passwords in our pipeline code, right? Not a good practice at all. So we can actually use a couple of different ways. If you're doing the username and the password, then you just need to have the credentials binding plugin installed and create the credential in Jenkins. Probably most people have done that. and define the username. And then there is a step or a block in the Jenkins DSL called with credentials. Again, you can go through the pipeline snippet or snippet generator code to figure that out. But it plugs in the username and password to environment variables. Now, there is an error on that code I'll tell you about in a moment. But basically, if you can look at the labs online, or if you can on there, you can see it's with credentials. You have a class that says username password out there. You have a credentials ID, which is just the ID of the credentials that you define in Jenkins. And then you have username variable and password variable. So the idea is with the credentials plugin, it's taking the information out of those credentials you define and plugging them into those variables. Then you can use the variable name in whatever step you need to access. So it's with the with credentials plugin takes the values from the credentials you define in Jenkins and substitutes them into the variables, so then you can use the variables in your access. There is a typo or an error in that line that says sh, it says env dot variable. The env doesn't need to be there. And so when you're doing these later labs, you'll probably need to take that env out. There's an env prefix for the environment. That used to work, it doesn't seem to work now, so you can take that out for that lab, for lab 4 through 6. Take out the or lab 3 through 6, sorry. Take out the env part of that $ variable name. But the basic idea is that you plug in, it will take the credentials and it will substitute them into those variables. If you're using SSH key, you need to have the SSH agent plugin installed. Same kind of ideas. There is an SSH agent block that passes in the ID of the SSH credentials for you to use. Integration testing. If you've ever used Java Gradle source sets, and probably most of you have, that's what we're leveraging in our project here for our integration testing. We have source sets defined, which actually then, instead of using, we have an integration test that's a source set, a functional test that's a source set in there, which then gives us task names of integration test and functional test in there. So the point of this is one way to define, if you haven't done it before, define additional testing sets in Gradle is to define these different source sets for those different things. And they can have their own paths, they can have their own runtime, compile time class paths in there, they can have their own configurations. Most of the time what you're going to do is do things like compile class path equals the main source set class output plus the test output out there, or you're going to keep kind of inheriting down, taking the stuff from the test into the integration test, taking the one from the integration test into the functional test. Okay. Databases in the project itself, the project is actually using environment variables in most places to be able to figure out which database to use. So the application that is actually being built on here is a web app with a simple MySQL database. We don't have time to go in and demo it here, but essentially, if you were to dig into the code, what it's doing is, for the integration testing, for example, it's referencing an integration test database. And the way it selects that, you can do that either through looking in environment variables out there, or we can define it even in the build.gradle file here. We have our environment variables that says points to the MySQL database out there for that particular registry, for that particular database. So the point of all this was one way to select like test databases and stuff in there is to use these environment variables to set that. And when you create those source sets as integration test or functional test, you get the nice kind of integration test output that you expect from Gradle as well. Okay, lab 4 was just using credentials and source sets. You're going to, in that one, you would go in and you would add a with credentials block. You can use the Snippet Generator to figure that out. I suggested using build now instead of doing the multi-branch scanning just to save on time. And then those two lines there, change the env db user to db user and change env db pass to db pass. Just get rid of the env in front of the environment variables. That isn't needed anymore. All right, again, I apologize we're going through this. I know I'm kind of dumping the fire hose at you, but at least you're getting kind of the background of a lot of this, and you can work through the labs separately. Sonar Cube. Anybody ever use Sonar? Yeah, a few people, okay. So Sonar or Sonar Cube, I keep calling it Sonar, it's what it used to be. It's designed to give you metrics and quality metrics for your code in there. Information there about what it's doing, example site, and so forth. On your system, on the virtual machine at port 9000, localhost 9000, there is an instance of SonarQube running. There is also an instance of Artifactory, if I forget to say it, at 8081. Both of those in some of the later labs, you'll see, you'll have an example. The pipeline will run a test through Sonar, an analysis of the project through Sonar, and it will also put stuff into Artifactory. But you can go out to those sites and look at it. Sonar has what we call quality gates, meaning you can have a set of criteria, how many blockers, how many alerts, how many kinds of errors or kinds of code problems am I willing to accept and say my project still passes. Okay? If you're not using Sonar or some kind of quality metrics, I highly suggest incorporating that into your pipeline. It can be a pain because it will find little things that you'll say, okay, throw this specific exception rather than just catching this. It's still good ideas, but it can be kind of a pain, but it gets your code to a better place. So you can define quality gates in Sonar that basically define which metrics you're willing to accept what values on to define whether it passed the test or not. So we can define quality gates in there. But in Jenkins 2, there's a nicer way or a better way to integrate it with the pipeline. What you can do is you can define a webhook in Sonar. Sonar has a way to define a webhook, and I take you through this in lab number 5, I think it is, doing this. Basically, you're defining a webhook out there, and what happens is when you call Sonar, Sonar runs the analysis through, and then when the webhook is done, it signals Jenkins. So you're setting up a webhook to point to say, Sonar, when you're done, signal Jenkins so that Jenkins can then say either I passed or failed. Okay? You can do Sonar analysis in a number of different ways, but basically the way you do it is you install a Sonar server, you install a scanner. In your pipeline, you invoke the scanner. There is a with SonarQube environment DSL method. Then you can define a webhook in Sonar, and you can define a thing in pipeline to wait. So it looks something like this. In our Sonar analysis stage, we might define a location of the Sonar scanner. And a scanner, if you're not familiar with that, is basically a little runtime standalone tool to go out and analyze your code. You define a configuration file to point to it. Then you have this with SonarQube environment. And if you have more than one scanner or server, you can point it to where that is. Basically, this is the name in the global configuration. Then we have a command, which is a shell call, to call out to our scanner and say, go off and run the scanner. So this will look at your project configuration. It'll go off and run Sonar against it, and Sonar will do the analysis. Then we can also have another stage, for example, that's a quality gate. Basically, if we've set up that webhook, then what happens is when Sonar finishes running its stuff, it will signal Jenkins to say, I'm done, and here's the results. So we can have another method in there called wait for quality gate. That is a Jenkins built-in method that essentially is waiting for that webhook. The webhook has to have a specific name, and again, this is all in lab number 5. But it has, basically, it sits there and waits for Sonar to signal that webhook, come back and say, okay, did I pass or not? And then you can do different things, depending on whether it passed or failed. You can actually do inside your build.gradle, since this is Gradle. Do you have a question?
Yeah, that was my question.
Okay. You can actually define a Sonar. There is a new integration with Gradle for a Gradle runner. They've changed this over time, but there is on this slide, and the slides will be available to you at some point after the class. But there is a SonarQube plugin that you can do, and you can run through it like this. All right. Now, the one thing about this, you set the properties, and that way you don't even have to have an external properties file. That all works for running the Sonar analysis. The one thing that's currently broken right now is it doesn't wait for the quality gate. So you could put this into your build.gradle file instead of running that in Jenkins, but the challenge is if you do that and then you try to use that wait for quality gate step in the DSL, there's a bug right now in Jenkins that it doesn't work. It'll come back and complain with an error that it can't find the project and information. Jacoco, I'm not going to spend too much time on this. Basically, Jacoco is line coverage analysis out there. This is set up. I don't have you do anything in the labs for it, but once I think it gets through like lab number 5, it runs through a Jacoco analysis. Jacoco can also be integrated into Sonar, but you'll see it shows you how to do code coverage. And in the build.gradle script, you'll see a line in there that shows you how to do the COCO coverage too if you want to do that. Mention this really quickly here, pipeline flow control. One of some things in Jenkins 2, you're probably used to being able to put parameters on your jobs. Well, now you have to think about how does that look in my pipeline code. The main key if you need to put parameters on your scripting in Jenkins is the input step. The input step then allows you to have different parameters. If you go into like the Snippet Generator and you define the input step, you'll see drop downs there. You can define Boolean parameters, the file type of parameters, whatever kinds you want. So remember, if you need parameters, go to the input step in there. There's also a retry loop in Jenkins. You can have an exception happens. Basically, it'll throw an error, and if retry limit is reached, exception occurs, then the processing is going to abort if handled, but you can retry it, keep retrying it. There's a sleep command. I think everybody knows what that does. Timeout. Timeout is a good one to put around other pieces because you don't necessarily want to have an input that's sitting there waiting indefinitely probably for somebody to go and give it input. You don't want to have it sitting there waiting for 5 hours. So you put a timeout command around it and it gives you a block of code with a certain timeout in there. And then the waits until if processing executes returns false, waits a bit longer and tries again. The idea here is I sit there, I try to execute code. If it doesn't complete and returns false value, basically what it does is it multiplies it by a factor of 1.2. It multiplies by 1.2, whatever more, tries it again. If it returns false, multiply by 1.2 again. The catch here with this would be you want to wrap it in a timeout probably, so it's not sitting there waiting again forever. You also may need to catch some exceptions internally and have it return false if you need to return something, if you need to have it processed. Because if it throws an exception, it's going to bail. But if you catch that exception and have it return false, go through there. Parameters in pipelines, different ways to access parameters, env parameter names, params.parameter name, or this $ parameter name. You can actually, if you're doing this in the web, in the Jenkins web interface, if you create a pipeline project instead of a pipeline script, you can define parameters in that job even above the pipeline section. So you can write your pipeline code in the pipeline block in that job in the interface, and you can define parameters above that, and it will be able to use that. It'll actually, you can also write your code, and it will create the parameters for you if you're in the application. So it kind of works multiple ways in there, okay? But different ways to include parameters in there. More examples of using parameters and input. I'm going to skip that for the sake of time now, but you'll be able to see that on the slide if you're interested. Workflow remote loader plugin. I mentioned this because it's nice to be able to load code, for example, from GitHub or an external Git repository if you want to. There is a remote loader plugin in there. It has a from Git method. So one of the things that we do in the pipeline, you'll have to kind of dig in to see this, is I actually have a set of shell commands stored in an external file on my GitHub site, update Gradle properties. And what I do is I pull this in, be it the remote loader plugin, and just have a shell step that executes it, and that goes out and modifies the Gradle.properties on the fly in that file. So if I don't want to have the parameters in the Jenkins job, for example, to modify it, I have this external code, and basically it just takes whatever parameters are passed that external code, writes it into the Gradle.properties file, and puts it out there. Some points this may come in handy to you. You want to pull in code from somewhere else, some other repository. So that step's available to you if you have the remote loader plugin installed. Skip over the assemble job right now. Code analysis, again, just remember to change those environment variables to take the env out. This is where in your Lab 5 you're going to set up the sonar stuff. It will also, when it's done, it will have sonar analysis. It will have Jacoco line coverage. It will have an Artifactory, our WAR file that we create, put into Artifactory. You'll be able to drill in and see all of those different things, and the labs talk about that. All right, publishing. If you're using Gradle, you know about publishing. You upload archives tasks, defining repositories that you can publish things to. Artifactory. Who's used Artifactory before? Good number of people, okay. Artifactory, basically like source control for your binary artifacts. That's the simple 2-second explanation out there. Various good reasons why you would use it. Now, this is a busy slide, and it is busy for a reason, because the Artifactory integration with Gradle in a Jenkins pipeline is not straightforward. I wish it was, but it's not. It also doesn't seem to work very well when you get into declarative pipelines, because you're having to do things like define values. Real quickly, if you find yourself working with a declarative pipeline is that second type of syntax that limits what you can do to give you the benefit of a more structured pipeline. If you find yourself working in a declarative pipeline and you need to do something like this, there is a script block. There is a script step or method or block. You can put that in a pipeline. You can do any kind of code you need to inside of that script block. The other way to do it would be to put this like in a shared library and bring that in. That's another way to do it, for example. I'll just kind of go through this quickly here. If you're using Artifactory with Gradle in Jenkins 2 pipeline, here's what you need to do. You have to create something that points to the server. Basically, this is the name of the server you configured globally in Jenkins. Then you create an Artifactory Gradle instance, which is a new Gradle build method out there. You point it to the Gradle tool name in Jenkins. Where's Gradle? We point it to Artifactory up here. Then we can define the deployment repositories. There's an Artifactory Gradle, this object we created up here, .deployer, repo, the .resolver, you can define a repo there, your repositories. If you're not using, or that Gradle's already including the Artifactory plugin, you don't need to pull in the plugin again. We can set the options to capture the build info, and so on and so forth. This is done in the pipeline, and here's the command to publish out the build info. I wanted to put this in the slide, so if you're converting things from Artifactory over there, you'll have this. What I would say is hopefully, and I've had the CloudBees guys even say this to me, you know, hey, why don't you kind of ping the Artifactory people and kind of say, hey, we really need this. Well, they're kind of pushing for Artifactory to find a simpler way to do this that works better with things like declarative pipelines. But at least the last time I checked, this was still the way you set up the configuration. If you go out to the Artifactory plugin for Jenkins 2, there's a whole section on using Gradle with that. There's a section on Maven and so forth on the plugin page. All right, this is all talking about things deployed to Artifactory. Let's cover the Docker stuff since we're about out of time. I think we've got about 5 minutes or so here. And we'll get you out of here on time. All right, so Jenkins 2 and Docker. 3 different ways of running Docker with Jenkins. One is you configure what they call a cloud. Now their definition of a cloud is essentially a Jenkins slave node that's running as a Docker image. Okay? It's essentially a Docker slave out there running Jenkins. You can also run it with built-in commands. So if you have the Docker pipeline plugin installed, not the Docker plugin, the Docker pipeline plugin, Jenkins will have a built-in Docker instance that you can then run steps against. You can use that. They call it a global variable. It's an instance in there. And then you can also just, of course, call Docker by the shell. The first one, the cloud, you have to have the Docker plugin installed, and you have to have a Docker image that can function as a standalone agent, basically what we call a Jenkins slave. It needs to have things like the slave.jar from Jenkins, Java runtime, and probably some kind of thing like SSH so it can communicate. Basically what you're doing, you're just set up a Jenkins slave on a Docker image. And that's what they're kind of calling the cloud here. That comes from the Docker plugin. If you want to go a step further though, like I said, with the Docker pipeline plugin, I know that's confusing, there's a Docker plugin, Docker pipeline plugin. If you have the pipeline plugin installed, then the plugin will provide a global Docker variable. Well, I'll come back to it if I have a moment. Basically, if you're going to the Snippet Generator, at the bottom of the Snippet Generator page, there will be a little line that says something to the effect of, lots of things in Jenkins are not functions, they're variables. Click here to see. And if you click on that, then you'll be able to see things like this Jenkins or this Docker variable that's in there. So it provides you a global Docker variable, which has an inside method. And this inside method does a lot for you. So you can have a Docker image, and then you can call an inside method on that. The inside method does all these things in bold. It gets an agent and a workspace for you, because the Docker stuff still has to run on a defined agent out there. It'll pull an image down if you don't already have a Docker image out there. It'll start the container up with that image. It'll mount the workspace from Jenkins. This assumes that you have file system access, that you're running on the same system. So if it can grab the Docker or the Jenkins workspace and mount that in that Docker image. Again, if it has file system access to it. As a volume inside the container, it appears on the same file path. So what this all means, and then anything in sh commands will be wrapped in a Docker exec. So essentially what this does for you is it creates this Docker environment where you've already got your workspace mounted inside as a volume in the Docker container, and anything that you run with an sh command within that with Docker container or that with Docker, inside, in the inside block, any sh command actually runs on the container. It's essentially putting a Docker exec on the front there. So it's doing all those kinds of nice things for you. It very much simplifies it. sh commands that are in that block will run as if they had a Docker exec on the front of them. At the end of it, it stops the container, gets rid of the storage, and creates a record. So this one command is spinning up your Docker container, mounting the volumes, giving you an environment where you just call the Jenkins shell call. It runs the stuff inside, and when you're done, it does the teardown. So very nice little feature there. You can also do with Docker container in there, and you can do the same sort of thing. It's what essentially the inside is doing. Here's other operations. Here's that global variable section that I mentioned. If you go to the Snippet Generator, at the bottom of that page, there'll be a little link there that says, hey, other things are variables, they're not methods. Click here. One of the other pieces you can do is you can define, for example, the docker.build. There's a build command. If you look at the things you can do for Docker variable, you can give it a Docker file name. You can create an agent, a node in Jenkins that is based off a Docker file. You can create other images off of Docker images and so on. Okay. And then you can also run Docker via the shell, of course. You can just shell out via the sh command and call the Docker executable that way. And here's some examples of doing that. All right. That's all. It's close to 11:04. I know that was like drinking from the fire hose in there, but again, the idea was kind of give you exposure to the different pieces here. You can take the image back, the VM, the labs, work on it in your spare time. If you have questions, email me, contact me, I'll help you with that, and you can kind of put together a little image and see how it all works. Okay? I hope it was useful to you. Thank you guys for attending. I appreciate it, and I hope you have a good rest of the conference. Thanks.